Hello, and welcome back to another episode of Low Spec Labs. Before we get started, I would like to say thank you for tuning into this channel. Thank you for commenting, thank you for subscribing, and if you're new to this content, welcome. I do automotive and IT focused stuff here. For right now, we're talking about Linux stuff, and once we're done with Linux stuff, we're gonna go into some automation stuff. But you gotta start with the fundamentals. So if you enjoy the content, hit subscribe. Otherwise, let's go ahead and get started. We're talking about chapter 16, basic Linux kernel management. What does basic Linux kernel management mean? Basic. It is basic, it gets pretty complicated. By basic, we mean understanding what the Linux kernel is. We mean understanding what tools and utilities we can use to manage it. We mean understanding where it lives in the boot process, and also means understanding what kernel modules are and the role they play in your kernel and on your system. So we're going to go into those 3 or 4 different topics in the next couple of minutes. So we're learning about kernels. The first question we should ask is, what is a kernel? In simple terms, a kernel is a program that acts as an interpreter between your applications and the hardware itself. So stuff like your hard drive or SSD. Then there is also your CPU, and then there's like your network. So your kernel is the middleman between your apps and your hardware. It not only does that, it does that and so much more. Look at that, I even wrote it down right here for you. Right, if you write it down, it's easy to remember. Now that we know what a kernel is, what is the Linux kernel? See what we did there? We asked one question and it led to another one. Things nest inside themselves often. The Linux kernel is an open source implementation of the Unix kernel. It was created, developed, and initially released by Linus Torvalds. In 1991, before Mr. Low Spec was even a mischievous gleam in his father's eye, Linus came out with Linux. See what he did there? The genius. Anyways, he came out with Linux, and it was initially a hobbyist project, but what he released was rather good, and it took off. And now 40 years later, his kernel is on millions of devices and runs more than half the world's infrastructure. On Linux system, the kernel does more than just act as a interface layer between your applications and your hardware. It does that, but it does a few other things too. So imagine these were your applications. This is the kernel. Below the kernel, you'd have your hard drives. Right here, you'd have your I/O stack. So this would be sound, network, keyboard and mouse. And then over here, you'd have various other system tasks that are needed to keep the Linux system running. So on Linux, your kernel does this, but it also does this, and this, and this. And when I say system tasks, what do I mean? Well, by system tasks, I mean stuff like cleaning up memory, like managing RAM, like even managing your tasks. If you were to run a PS and open a task manager, you're actually opening a PS from the kernel, and it's the kernel that manages the task. Let's talk about the kernel even more. I know, such a riveting subject. It brings joy to my heart, boys. Recall that your Linux kernel is the interpreter between your hardware devices and your applications. It communicates with your CPU, your memory, and additional devices like your keyboard, mouse, network stack, and even your hard drives. Because the kernel is the interpreter of all these additional devices, the kernel is where your drivers live. So if you've ever used a Windows computer and you tried to plug in a new device like a USB stick, you'll notice it beeps at you. After it beeps, it pops up with a little message that says installing device drivers. Well, device drivers are what computers need to communicate with the low-level hardware of your device. And on Linux systems, those drivers are included inside of the kernel itself. This means if you have bad drivers in your kernel, your system breaks. What? I know, terrible design choice. But no doubt it was one made based on the technical limitations of that time period. Did I change my shirt? Are you even paying attention to that? I don't know. Let me know in the comments below. On Linux, there are two types of kernel modules. Those two modules are open source and closed source. So basically on Linux, you have a choice of either going with proprietary closed source drivers, which will give you a tainted kernel, or you can be a cool kid and go with the open source drivers and maybe not have all the functionality, or perhaps you will have all the functionality. Like most things on Linux, it depends. Generally, it depends on how much money is involved. With NVIDIA, there's a lot of money involved with their drivers and their GPU hardware, so the drivers tend to be closed source and the open source versions are not very good. With AMD, the open source drivers are actually the better version because they're properly supported by the community. The more you know. We are now logged back into our system. The kernel is running. How do we figure out what it's doing? You've heard me say this many times over several months. There is a utility for that. Actually, there's more than a few ways we can look at our kernel log messages and figure out what's going on with the system. The first is a dmessage. So let's go ahead and get started with dmessage. So we do dmessage, and as you can see, when we ran dmessage, we immediately had a bunch of different output. So these are the different kernel messages from our system. As you can see, a lot of it is related to hardware devices. So you can see right here, we got Intel, right? We have RAID 6. Let's see. It's telling us we're having some IO errors. We have Ethernet. Lots of different information, most of it relating to the hardware of the system itself. Remember, a kernel is an interpreter between your applications and your hardware. So it makes sense that when you have hardware issues, you're going to see that using dmessage, which is your kernel log viewer. One thing to keep in mind about dmessage is that it shows you your kernel messages since the kernel first started. So basically, these events right here are the number of seconds that have passed since the system started up. In my case, it is 258,873 seconds. Another command that'll let you view what's going on with the kernel is the uname command. In this case, it gives you information about the kernel, like its version. So if we were to do uname -r, you would see it shows us our current version is 5140-362.81.el9. The Linux kernel is modular. What does that mean? That means that the kernel itself is a small core application, and then you can gain additional functionality to the kernel by loading modules. So if I wanted to add a Intel network card to my server, I'd probably want to load the Intel modules. If I wanted to add a AMD graphics card to my server, I'd want to load the AMD modules, etc., etc. How does the Linux kernel load the kernel modules? I'll see if I can explain that to you in less than 60 seconds. Imagine the diagram to the left or to the bottom represents your Linux system from a very high level. On your system, there's your Linux kernel. Your kernel is split into two parts. There's the core kernel, which is right here, and then there's modules that are loaded by the core kernel. Both the core kernel and the kernel modules then talk to applications and hardware. Something you should take note of is that the core kernel, number 1 down here, acts as not just the middleman between apps and hardware, but also as the middleman between apps, hardware, and your kernel modules. What that means is if we have an issue with our hardware, we can easily check our kernel modules and diagnose if we have a software or a hardware problem. In the same way, if we had applications, let's say special file systems, we would load those file systems once again using kernel modules, which are loaded by the core kernel. How does the kernel initialize hardware devices? Step 1. The kernel looks for hardware devices on your system after boot. Step 2. A process known as systemd udevd loads your kernel modules based on information the kernel found. Then it's time for step 3, which is when systemd udevd reads a file at user lib udev rules.d. The files contained in user lib udev rules.d are going to decide how your hardware devices are initialized. Then it's time for step 4. In step 4, once again, systemd udevd looks at another file. This time that file is at etc udev rules.d. So basically inside of this folder is going to be your custom rules for loading your modules or your drivers. And that's it. Those are the 4 steps that the kernel uses to look for and load hardware. There is one last step that happens after the hardware is loaded, and that is step 5. Once the kernel has initialized those hardware devices, it goes ahead in step 5 and mounts those hardware devices to a virtual file system at /sys. So every time you look at your Linux file system and you see /sys, that is technically your hardware devices mounted on that system. Hello and welcome back to another episode of Low Spec Labs. In our last video we talked about kernel modules and how they're loaded and how the kernel interacts with them. That's all fine and well, but we should probably learn how to actually manage the kernel. There are about 4 to 5 utilities we can use to manage the kernel. In these videos, we're going to go through those utilities. Let's start at the beginning, because we always have to start somewhere. So, the first command we need to learn is lsmod. What does the lsmod command do? It lists your currently loaded kernel modules. That's actually very useful. So when we run lsmod, you can see all the different kernel modules we currently have loaded into the system. Quite a number of them here. Now that we know what kernel modules we have loaded into the system, what if we wanted to get some information about a module? Let's say we wanted to get information about this RAID 0 module here. Well, to do that, we would do mod info RAID 0, and as you can see, we now have information about that kernel module. You can see it gives us an alias or different aliases. It gives us a description. It gives us a license. It gives us a release. All very useful information. This piece of information right here, vermagic, shows us the version of the kernel module. And this is useful because we might need to upgrade a kernel module to get additional features, or we might need to downgrade a kernel module because an update broke that module, which sometimes does happen with Linux. What if we want to load a kernel module? You know, we got some information about it. We found the module. How do we load it? To do that, we do a mod probe. So that would be mod probe, and then we do RAID 0 again, and that's it. We loaded the kernel module. Finally, we should learn how to unload a kernel module. How do we go ahead and do that? Let's walk through it real quick. So we know how to load kernel modules. How do we actually troubleshoot them? Well, when troubleshooting kernel modules, you have to remember what they are. They are essentially drivers that add additional features to your Linux kernel. That said, because they are drivers, your hardware devices are attached to kernel modules, and oftentimes when you have kernel module issues, they're going to be hardware related. How would you troubleshoot that? There is a command for that. Oh, I know, you're probably tired of hearing those words. Get used to them. Let's talk about that command. The command is lspci. What that does is, like it sounds, is it lists our PCI devices. As you can see, it lists all the different PCI devices we have attached to our server. What we then do is run lspci again, but this time with the -k flag. And what that does is it shows us those PCI devices. Notice this output versus this output. So lspci-k gives us our PCI devices, but it also lists the kernel modules attached to them. So let's say we were to plug a new device in. Well, if we were to plug that new device in and we were to see it being detected on our PCI bus, but it has no modules attached to it, that means we have a problem. Either we don't have the module loaded, or basically we don't have the driver installed, or we have a bad module, which is possible, or we have an outdated module, which is also possible, or we have broken hardware or broken low-level firmware, which is also possible too. Did you know kernel modules have parameters? That's right. Just like kernel modules add features to the Linux kernels, the parameters inside of the kernel modules enables or disable features on the module. So the kernel module adds a specific feature and the parameters go ahead and toggle sub-features of that feature on or off. I tried my best to make that as simple as possible, and even then, I had verbal diarrhea. All right, let's go ahead and get started. Let's do a ls mod grep cd-rom. As you can see, it shows us which two modules are loaded. So we have ISOFS and srmod are both using the CD-ROM module. If we were to try to reload that module by doing mod probe-r for reload CD-ROM, you'll see we're not able to reload that module because it's currently in use by ISOFS and srmod. The easy fix for that error is to just unload those two modules. Let's give that a shot. So let's do a mod probe-r ISOFS, and then we do a mod probe-r CD-ROM. Oop, I see what I did there. Added an extra E on that second command. And notice how we use the colon to separate these into two separate commands. As you can see, it tells us we're unable to do that. Let's try CD-ROM to srmod. As you can see, we're still unable to do it. I actually have a CD mounted to a location on our file system. Let's take a look and let's see ls block. And then if you look at ls block, that's a bunch of information that's not useful. Let's grep that to just our CD, which is at SR. As you can see, we have a CD there. So what we want to do is we want to unmount that /dev/sr0. Once we have dev sr0 unmounted, then what we do is run another ls block to confirm that it's unmounted. Then we can run our previous mod probe command, and as you can see, that one's completed successfully. And then if we were to do it again, we could do mod probe-r CD-ROM, and there we go. We have now unloaded the ISOFS module, the srmod module, and the CD-ROM module. We then do a mod info CD-ROM. So to do that, we do mod info CD-ROM, and then when we look at our mod, we should be able to see the parameters or the options we can load this module with. Let's scroll through and see. Here we go. We've got some parameters. We've got debug, auto close, auto eject, lock door, check media type, and then check media read write format restart. So what if we wanted to load that module with the debug option enabled? Well, we would just type that option in with the module command. Let's practice it. After hours of research, I was able to find the command. We are going to go ahead and do a mod probe CD-ROM debug equals 1. And there we go. So because last time we ran that mod info on CD-RAM, you can see debug is Boolean, meaning we set it to a value of 0 for disabled and 1 for enabled. And that is it. Before we depart ways, I'd like to say thank you for watching. I appreciate your feedback, your commentary, your likes, and your subscriptions. Please keep tuning in for some more content, and I'll keep putting these out as I continue reading through this series. Before we go, let's summarize everything we covered in this video. First, we covered what a kernel is. Second, we discussed what the Linux kernel is. Third, we discussed kernel modules and what they are. Fourth, we discussed how to manage kernel modules, loading them, unloading them, reloading them, and loading them with special parameters. We even covered kernel module parameters, which are sub functions you can enable or disable inside of a kernel module.